Look at this massive steel drill casing driving into the mud. It looks like chaotic, heavy labor, but highway bridge construction is actually a rigid, zero-tolerance exercise in applied physics and geometry. Over the next 6 minutes, we're following the progression of this site as it evolves from the first laser-aligned pile in the dirt to the final painted traffic lines. But before any of that starts, 2 non-negotiable conditions must be met. The site has to be completely leveled, and the survey lasers must be perfectly calibrated. This specific sequence of operations determines how the finished bridge will eventually handle weight. If the physics are ignored at any step, the integrity of the entire structure is compromised. Down at ground level, everything depends on precise tripod laser alignment. These invisible lines dictate the success of the entire project. A laser receiver is synced to those lines, giving the crew the exact coordinates to align the steel piling casing before it ever breaches the soil. This diagram illustrates the displacement method. Groundwater is pumped upward and out of the cylindrical void, while dense granular sand is simultaneously injected under high pressure to fill the space from the bottom up. Next, the foundation casings have to be lowered. This is a slow, methodical process to prevent the surrounding soil from collapsing inward. This blueprint schematic shows the wooden formwork rings used to shape the concrete piers. Notice the red highlighted arrows. They indicate the intense outward shear stress acting on the structural locking bolts as the rings are sequentially stacked and tightened. To handle that stress and form a solid pier, the concrete pour into these forms must be a continuous, steady flow. Any interruption creates weak, brittle joints in the column. Once the concrete cures and the wooden forms are stripped away, the completed substructure is revealed. These piers will now permanently transfer all future overhead weight deep into the bedrock. Moving up from the ground, we reach the top of these newly cured, exposed concrete piers. The first addition here is the structural bearings. These critical structural bearings create a highly necessary buffer between the rigid columns below and the dynamic, shifting bridge span above. Massive precast concrete bridge girders are hoisted by heavy cranes, carefully aligned and immediately braced into place across those bearings. With the girders suspended, crews lay out bundles of flexible steel rebar across the new surface. This diagram shows a top-down view of the structural grid. Crews tie intersecting lines of steel, locking them into a unified geometric mesh. This matrix takes localized weight from a single pressure point, distributing it evenly across the bridge span. Concrete is then pumped over the grid and carefully leveled, fully encapsulating the steel matrix to form the smooth highway deck. Combining the tensile strength of the steel mesh with the compressive strength of the concrete transforms thousands of separate pieces into a single, highly durable monolith. While the deck cures, attention shifts back to the sides of the bridge, where the dirt approach ramps are still vulnerable and uncompacted. Crews continuously dump, spread, and heavily roll the dirt, aggressively compacting the approach roads. During this phase, a critical safety protocol is enforced. This graphic highlights the bridge deck with a flashing red quarantine boundary. Heavy dump trucks are restricted strictly to the dirt approach zones to prevent structural failure on the uncured deck. Once the concrete structural integrity is officially confirmed, heavy paving machines are deployed onto the deck in a coordinated parallel formation. They continuously spread and roll the final asphalt mix, securing a perfectly level driving surface. Next comes the vertical infrastructure. Mounts are drilled, light poles are lifted into place, and structural bolts are tightened down along the outer edges. The final precision step is marking the exact highway center and edge boundary lines. These final layers of pavement and paint guide high-speed traffic and seal the structural concrete against long-term environmental decay. Pulling back, we can see the fully integrated system. The initial muddy dirt pit has been replaced by organized, finished infrastructure. Every step was strictly controlled, from sinking those first laser-aligned foundations to deploying the heavy-duty decking. Adhering perfectly to that sequence, maintaining exact alignment, and respecting loading protocols prevented any invisible structural compromises from taking root. Now, with the site cleared and the heavy machines gone, this engineered span is ready to safely absorb and distribute the continuous kinetic energy of maximum capacity highway traffic.